Thank you for joining me for PCI DSS version 4.0 in the public cloud, how to achieve compliance simply and affordably. I'll be covering the following topics in this presentation: a brief overview of the cloud, a review of scope as defined within the PCI data security standard, common cloud deployment scenarios, the delineation of responsibility between cloud providers and cloud customers, available compliance resources provided by the three major public cloud providers, and key takeaways for this session. My name is John Noltensmeyer, and I'm the Chief Technology Officer at TokenX. I have over 20 years of IT experience, primarily in information security. At TokenX, I work with our global client base to meet their data security and compliance obligations. In addition to being a PCI ISA, I hold a number of other vendor and industry security and data privacy certifications. Thanks again for taking the time to view this presentation. I won't spend a lot of time extolling the virtues of the cloud generally, or why organizations are continuing to shift increasing amounts of their IT infrastructure to the cloud, but I do want to touch on the following cloud benefits and concepts as they relate to the processing of payment card data and PCI compliance. The Cloud Security Alliance defines 5 essential cloud characteristics, one of which is rapid elasticity, or the speed at which you can scale a cloud environment both horizontally and vertically. Scaling vertically generally refers to using more powerful components, such as 4 CPU servers instead of 2, while scaling horizontally refers to adding additional resources to support cloud workloads. The speed at which organizations can scale in the cloud also contributes to its affordability. Just as you can scale up, you can scale down, right-sizing cloud resources to meet demand. This is typically referred to as utility computing or pay-as-you-go model, without the capital expenditures required in traditional computing of physical data centers, such as the acquisition of dedicated hardware. A third cloud benefit worth noting is flexibility. There are several deployment models that can be utilized to meet an organization's technology and computing requirements. The first deployment model is public cloud, which simply means that the cloud provider is a third party accessible to anyone with a web browser and a credit card. Amazon, Microsoft, and Google are currently the 3 largest cloud providers, although there are others such as IBM and Oracle. The next deployment model is referred to as a private cloud. Private in this case means that the environment is built for a single organization. A private cloud can be managed by a third party or an internal IT department. Next is the hybrid model, which has come to refer to an architecture that includes an on-premise, non-cloud data center that is connected to a cloud environment. A hybrid model is often used for redundancy for a physical data center or for the use of cloud-specific resources such as a data warehouse. A hybrid model may also be used for bursting to the cloud when resources of an on-prem data center aren't sufficient to meet demand. Multi-cloud, as the name implies, refers to a deployment model that spans multiple cloud providers. This is increasingly common as organizations take advantage of cloud-specific services. Finally, cloud categories or service models are used to describe the resources the cloud provider makes available. The service models are relevant to our discussion of compliance because each model has a different delineation of responsibilities between the cloud service provider and the cloud customer. It is often referred to as the shared responsibility model. In the software as a service or SaaS model, cloud customers utilize the cloud service provider's applications running on the service provider's infrastructure. In the PaaS or PaaS model, cloud customers can deploy their own application on cloud server provider's infrastructure. In the IaaS or IaaS model, cloud customers use the provider's cloud infrastructure to run operating systems, applications, or other software. Generally speaking, the cloud customer has responsibility for any aspect of the cloud environment that they can directly configure, and the cloud provider has responsibility for everything else. Consequently, the cloud customer's responsibility is greatest in the IaaS model, with decreasing responsibility in the PaaS and SaaS models. AWS Fargate, a serverless compute engine, is a good example of this. Cloud customers are responsible for the application containers and defining networking and identity and access management policies, but not for the underlying virtual machines. We'll discuss the delineation of responsibilities and how it impacts PCI DSS compliance in more detail in an upcoming slide. Each of the 3 largest public cloud providers have comparable service offerings, although there are subtle differences in their functionality and naming. For example, each provider has a serverless computing option, AWS Lambda, Azure Functions, and Google Cloud Functions. Similarly, each offers comparable compute, storage, and containerization resources, which are detailed in the presentation notes. Because of their size and similarity, I'm going to focus on the PCI compliance resources offered by these three cloud providers later in the presentation. Before I continue to discuss PCI compliance in the cloud, it's important to review the concept of PCI DSS scope. The people, processes, and systems within an organization that store, transmit, or process cardholder data or sensitive authentication data comprise the cardholder data environment, or CDE. The CDE is in scope for the requirements and corresponding controls in the PCI DSS. Scope is depicted in detail on this chart, which you may recognize from the PCI Data Security Standard. The CDE is on the left side of the chart. Note that any system components that are on the same network as the CDE or have unrestricted access to cardholder data are also in scope. The number of system components that are in scope often directly relates to the complexity and cost of a PCI DSS assessment. One of the primary strategies to reduce an organization's scope is segmentation of the CDE from all other systems that don't store, process, or transmit cardholder data. Segmentation is often accomplished using firewalls or routers, and system components that are used to segment the CDE from other systems or systems that otherwise impact the security of the CDE, such as domain controllers, are also in scope, as detailed on the right side of the chart. Segmentation and PCI scope are important considerations for organizations that have a cloud deployment. The cloud can be used to reduce PCI scope, or it can significantly increase it. For organizations that have a card data environment, there are four common deployment scenarios. The first is no segmentation of the card data environment. Many organizations still maintain flat physical networks and do not restrict access to their CDE from other systems, effectively creating one large card data environment that encompasses the entire environment. Cloud deployments that do not directly process cardholder data are in scope if they have unrestricted access to system components that do store or transmit or process cardholder data. Even for small environments with no segmentation, PCI compliance can be complex and costly. For organizations with flat networks, the cloud may represent an opportunity to begin segmenting system components that process cardholder data. A second common scenario is a physical CDE segmented from the cloud environment. Isolating a physical CDE from an organization's cloud deployment can remove cloud system components from scope, reducing the complexity and potential cost of a PCI DSS assessment. Some organizations maintain a segmented CDE that spans a hybrid or multi-cloud deployment. A CDE that spans both a cloud and physical environment will retain much of the PCI DSS compliance complexity faced by organizations with flat physical networks and cloud deployments. However, segmenting the CDE from systems that don't process cardholder data can substantially reduce the number of system components that are in scope. PCI compliance for a multi-cloud CDE can also be complex since the in-scope system components span multiple cloud providers. Finally, some of the organizations segment their CDE within a single cloud provider's environment. It's important to note that the cloud system components used for segmentation must provide the same level of isolation as physical network separation. Fortunately, each one of the three primary cloud providers offers resources to help organizations achieve PCI compliance within their environments. Many of the same PCI DSS compliance recommendations or considerations that apply to a physical data center also apply to the cloud. First, you should minimize the number of cloud system components that store, process, or transmit payment card data. This is the most effective way to reduce the PCI scope of a cloud deployment. Use technologies such as tokenization to devalue cardholder data. Tokenization is the process of replacing a primary account number or PAN with a non-sensitive equivalent or token. A token is not considered to be cardholder data, so tokenization can significantly reduce your PCI DSS scope. Next, if you do process cardholder data in the cloud, implement a defined infrastructure to support in-cloud operations. Scoping will be simplified if a cloud CDE is made up of a defined set of virtual and supporting physical systems that are segmented from all other system components. It is important to remember system components that can decrypt or detokenize cardholder data are considered security impacting and therefore still in PCI scope. It's also important to remember that use of a PCI DSS compliant cloud service provider doesn't mean that you're automatically PCI DSS compliant. PCI DSS compliant cloud services can be configured to meet a customer's PCI DSS requirements, but the implementation and use of the service must be assessed. Finally, an attestation of compliance, or AOC, is a point-in-time reference, but compliance is a continual process. Many organizations fall out of PCI compliance between their annual assessments because of changes implemented within their environments. The flexibility of the cloud and the ability to make rapid changes can make continued compliance a challenge. Cloud customers and cloud providers have differing compliance responsibilities. This is often stated as customers have responsibility for security in the cloud and providers have responsibility for security of the cloud. Cloud customers are responsible for the ultimate security of cardholder data. As mentioned on the previous slide, use of a PCI DSS compliant service provider doesn't automatically equate to PCI compliance. When selecting a cloud service provider, an organization should carefully vet them prior to establishing a relationship. Even though a cloud provider may claim to be PCI DSS compliant, the customer must confirm that all services that are used by the organization are included in the PCI DSS compliance validation and monitor the provider's continued compliance status. The cloud customer must also understand how a cloud provider's services correspond to each of the applicable PCI DSS requirements and the responsibility the provider is accepting. The cloud provider is always responsible for the cloud infrastructure, including the data center, physical hardware, and hypervisor. The cloud provider owns the segmentation between cloud customers and must attest that it is effective and provides adequate isolation. And finally, the cloud provider is responsible for any service impacting the PCI DSS compliance of the customer, but outside the customer's control, such as a managed service security service provider. Now I will highlight the available PCI compliance resources provided by each of the three major public cloud providers, beginning with AWS. Links to each of the resources described are in the presentation notes. Even though AWS has PCI DSS compliant offerings, customers must confirm that all services they are using are included in the AWS PCI DSS compliance validation and that services that are being used are used in a compliant manner. A good rule of thumb is that if a customer can set the configuration of a service, then they are responsible for setting it appropriately to meet PCI DSS requirements. The first resource highlighted on this slide is an AWS Quick Start titled PCI DSS and AWS Foundational Security Best Practices. This Quick Start deploys automated workflows to remediate deviations from the PCI DSS. There is also a corresponding guide that provides instructions for deployment using CloudFormation templates and leveraging the AWS Security Hub. The CloudFormation templates automate the provisioning of all required parameters to run security remediation workflows. The next resource is the Payment Card Industry Data Security Standard 3.2.1 on AWS. This is a PDF compliance guide that documents PCI DSS requirements and controls relative to the AWS environment and helps customers prepare for the PCI assessment of their AWS workloads. The AWS shared responsibility model from this guide is captured on the slide and shows the customer's responsibilities and those that fall to AWS. AWS compliance documentation, including the AWS Attestation of Compliance, or AOC, and PCI reports are available via the AWS Management Console using AWS Artifact. Like AWS, Microsoft makes its PCI DSS compliance documentation available via the Microsoft Service Trust Portal. Both the Azure PCI DSS Shared Responsibility Matrix as well as the PCI DSS Attestation of Compliance are available. A portion of the Azure PCI DSS Shared Responsibility Matrix is captured on the right side of this slide and describes the testing procedures for each PCI DSS requirement and notes whether it is the responsibility of the customer, Azure, or shared. Next is the Azure Policy Regulatory Compliance Built-in Initiative. Azure Policy helps to enforce organizational standards and assess compliance by comparing the properties of Azure resources against business rules known as policy definitions. Multiple business rules can be grouped together to form a policy initiative. Microsoft offers a built-in initiative for PCI DSS compliance. Google offers a guide for PCI DSS compliance in GCP, which helps assist GCP customers implement the PCI DSS in Google Cloud. This is an excellent guide worth reviewing regardless of which public cloud provider you utilize. Like AWS and Azure, Google has a shared responsibility matrix that delineates the responsibilities for PCI compliance within GCP. Lastly, Google's third-party audits are available in the GCP Compliance Reports Manager. The PCI DSS was updated from version 3.2.1 to version 4.0 to include an example of cloud systems and components under Section 4, the scope of PCI DSS requirements. That update is captured on this slide. Additionally, the guidance for how to understand and meet many of the PCI DSS requirements now include references to cloud systems and components where appropriate. There are 4 key takeaways from this presentation. First, minimize the number of cloud system components that store, process, or transmit payment card data. This is the most effective way to reduce the PCI DSS scope of a cloud deployment. Next, if you do process cardholder data in the cloud, implement a defined infrastructure to support in-cloud operations. Scoping will be simplified if a cloud CDE is made up of a defined set of virtual and supporting physical systems that are segmented from all other system components. Remember that use of a PCI DSS compliant provider doesn't mean you're automatically PCI compliant. View your cloud provider as a partner in protecting cardholder data rather than assuming all responsibility has been completely outsourced. Finally, an attestation of compliance is a point-in-time reference. Compliance is a continual process. Changes made by the cloud provider or cloud customer can invalidate compliance between annual assessments. A number of resources that were cited within this presentation are captured on this slide, and links are available in the notes. Thank you.